Find the size of the angle marked x correct to one decimal place. So if we call the angle we're trying to find A, the side opposite that is A, and then these could be B and C in any order really. Once again, we can see we wouldn't know a complete row of my table. We don't know B and B, we only know small b. We don't know C and C, we only know small c. And here we're trying to find the angle A. So once again, that's the cosine rule. Now if we're finding an angle, we usually rearrange to cos A is b squared plus c squared minus a squared over 2bc. So that's going to be 6 squared plus 5 squared minus 7 squared all over 2 times 6 times 5. So A would be the inverse cosine of all of that. 6 squared plus 5 squared minus 7 squared over 2 times 6 times 5. And then we can calculate that. So the inverse cosine of 6 squared add 5 squared take away 7 squared all over 2 times 6 times 5, and that gives me 78.5 degrees, like so. Now note, there's no possibility of an ambiguous case with the cosine because the cosine is not positive at all in this region here. So if our expression for the cosine is positive, we'll end up with an angle in here. If it's negative, we end up with an angle in here. And there's no possibility of confusion as there is with the sine. Now we could have done that just by solving on the calculator, in which case we wouldn't need to rearrange. So, like so, substituting in what we know, we've got 7 squared is 6 squared plus 5 squared, take away 2 times 6 times 5, times cos x. And action, advanced, solve. And we have 7 squared is equal to 6 squared add 5 squared take away 2 times 6 times 5 times cos of x, and we should do that given that x is between 0 and 180, since we're in a triangle. The equation itself would have an infinite number of solutions, so let's avoid that situation. And if we execute, we just get the 78.5 degrees.